For task 2, it's called Which One Grows Faster? So we're going to look at pattern A, where the length and width of a rectangle grow by 1 square from each pattern to the next. So step 0, we have a 0 by 0 square. Step 1, a 1 by 1 square. Step 2, a 2 by 2 square. Step 3, a 3 by 3 square, and so on. So what we're going to do is just fill in the information for that right here. So remember, step 0, if we had to fill this table out, it's a 0 by 0 square, or 0. Here, it was a 1 by 1 square, and 1 times 1 is 1. Here, it was a 2 by 2 square, and 2 times 2 is 4. Here, a 3 by 3 square, so remember, we're doing 3 squared, or 3 times 3, is 9. So if it's a 4 by 4 square, 4 squared, or 4 times 4 is 16. 5 squared is going to be 25. 6 squared is 36. 7 squared is 49. And 8 squared is 64. So in looking at this, to write an equation to represent the small number of squares at step n, so we'll just say y is equal to the number of squares, or the step number, so y is the number of squares, is equal to the step number squared. So if I plugged in step number 15, we would go 15 squared would give us a total amount. Now, this function is going to be quadratic. And it's quadratic because the step number is taken to the second power. So it's quadratic because of the n squared term. So we're going to go back to the second pattern. So here, step 0, we started at 1. Step 2, we're at 2. Or, I'm sorry, step 0, we're at 1. Step 1, we're at 2. Step 2, we're at 4. Step 4, we're at 8. So I'm going to fill in those numbers. So it went 1, 2, 4, 8. Now, if you notice, to get to the next number, I'm doubling. So here, we're going to go to 16, 32, and so on. So on here, this is an exponential function. And remember, an exponential function is of the form y equals a times b to the x power, where a is your starting value or initial value, and b is your growth factor, or what you multiply by. So in this situation, we would start off with y equals 1 times 2 to the x, or we can get rid of that multiplying by 1 and just write this as y equals 2 to the x. So here we could write this as 2 to the 6th power, and you could work that out with a calculator if you wanted to. So that would mean you would have on here, to fill this in, you just put in 2 to the 6th, which is 64. And you notice I could have also gotten that by taking 32 and multiplying by 2. So to get the 7th one, we can go 2 to the 7th, which is 128. And 2 to the 8th, which is 256. Now, the reason the equation is very helpful is if I ask you now to all of a sudden figure out, well, how many is in step number 30, you could say, well, all right, that means 2 to the 30th power. Whereas if you just knew multiplying by 2, you'd have to fill out the whole table. So what I want you to notice is that the exponential function grows much more faster. So the exponential function grows faster?